Hi, I'm going to do problem number 4 on page 211. That's section 5-7. So let me see if I can get my pen working here. All right, cool, I can. Section 5-7, and it's problem number 4. Problem 4. So what we have here, you can see the car. It's at moderate speeds, the costs reach a minimum. Assume, therefore, that the number of cents per kilometer varies quadratically with the number of kilometers per hour. The kilometers per hour. So the number of cents per kilometer varies quadratically with the number of kilometers per hour. All right, now suppose that it costs 28, 21, and 16 cents per kilometer to drive, and 10, 20, and 30 kilometers per hour, respectively. Write the particular equation for this function. And now the hard part here is to decide what's going to make the most amount of sense. And what makes the sense here is actually if you take 10 kilometers per hour, okay, and you pair that up with 28, I believe it's respectively, so this is going to be 28 cents. It costs 28 cents per kilometer to drive it. If you drive it at 10 kilometers per hour, it costs 28 cents per kilometer. And that makes the most amount of sense because if you give me a speed, I could tell you what it's costing you to drive that car. There's always a cost to the car, okay? And so then the next one would be, what would it be, 20 kilometers per hour. That would map to, it's costing you about 21 cents, okay, per kilometer to drive. And then if you drive it at 30 kilometers per hour, it costs you about 16 cents. 16 cents per kilometer to drive. So, the faster you go, the less it's costing you. To a point. Then there comes a point, though, where there's going to be a lowest point, a least point, and that's really what they're asking you on the last one there. How fast can you drive it to get the lowest value? Because then after you go past a certain speed, it's going to actually cost you more per kilometer. It's going to start climbing up again more and more and more the faster you go. All right, so here we go. We want to find the particular equation that satisfies these 3 data points. And I think this was the trick on this one, is to get the data points. You give me a speed, and I'll tell you what it cost. You give me a speed, that's the independent variable, and I'll give you a cost, that's the dependent variable. All right, so the first equation here, 28, is going to equal 100a, right, plus 10b plus c. You can see that, right? And then, so it's just that linear equation now, the coefficients, right? And then 21 is going to equal 400a plus 20b plus c, and then 16 is going to equal 900a plus 30b plus c. All right, then I did the matrix function and I typed it into my calculator, and I found out that y, but keep in mind what y is. Look at what y is up here. Y, the y variable right over here is the cost per kilometer. So the cost per kilometer, when I figured this out, I think I got a is 0.01. Let me see if I can find the paper here. Yeah, a is 0.01. Just putting this in a matrix and doing reduced row echelon form. B is -1, right? And C is 37. That's what I found using RR, the RREF function. And so what I get here is y is going to equal 0.01x squared plus, or actually I got minus. All right, minus x plus 37. That's what I got. Putting in 110, 128, 420, 121, then 931 and 16. So I put those into my calculator. I did RREF, and I got A is 0.01, B is -1, and C is 37. And so this is what I get from my quadratic equation. All right, then on B, it says How much would you spend to drive at 150 kilometers per hour? Okay, so remember, you give me a kilometer per hour, how fast you're driving, and I'll tell you what it costs to drive per kilometer, what it costs to drive your car. So if you're going to drive your car at 150 kilometers per hour, it's going to cost a lot. I don't even know that a car can go that fast. So y is going to equal 0.01 times 150, right, squared, minus 150 plus 37. And I think when you do this, you're going to get 112. Y is 112, I think. I guess let me just absolutely make sure on that. But I can't remember. I just did this a minute ago. 0.01 times 150 raised to the second minus 150 plus 37. There we go. Yeah, 112. All right, which means that it's going to cost you $1.12 per kilometer to drive it that fast, which is way more than driving it slower. And that's how much wear and tear you're putting on the car when you drive fast. So slow down, guys, okay? Plus speed kills, right? Typical mom here. All right, what's the next one? Between what two speeds must you drive to keep your costs no more than 13 cents per kilometer? So here's my particular equation again, and let me see if I can get some extra room here, because I don't need this anymore, right? All right, now I know my particular equation. It is y equals 0.01 x squared minus x plus 37. All right, and I don't want, let's see, to keep your costs no more than 13 cents per kilometer. So in other words, I want y no more than 13 cents. So 0.01 x squared minus x plus 37 has to be no more than, so less than or equal to 13 cents. And so I'll just solve this equation right over here, and we'll get 0.01 x squared, right, minus x, and then subtract 13. What do I get there? Plus 24 is less than or equal to 0. All right, and then I'll just solve this, solve this for x and see what I get here using the quadratic formula. What x would make this equal to 0. Of course, it could be anything greater than that. You can pick any x greater, but that'll be the baseline, So if I just use the quadratic formula, right? So it's going to be the opposite of b. Remember, b is -1, so it's going to be 1 plus or minus radical b squared, which is 1, minus 4 times a times c, okay, over 2a, 2 times 0.01. I recommend you do your numerator first and then divide it by the denominator. Okay, and then when I do, so this is going to equal 1 plus radical, whatever that is, I don't know, let's see, 1 minus 4 times 0.01 times 24, what do I get there, 0.04? Over, and then 2 times 0.01, and I get 0.02. Okay, that's the first one. Or it'll well, actually it's going to be less than or equal to this, or it's going to be less than or equal to 1 minus 0.04 over 0.02. And I think when you do this, you get that it's less than or equal to 60. You get 60 here. Or you get 40 over here. When you subtract off, you get 40. And that's going to be kilometers per hour or kilometers per hour. I think if 1 minus x is going to be, does it make sense to be one or the other? Anyway, it's going to be between 40 kilometers per hour and 60 kilometers per hour. Somewhere in there. Is that what the question is? Is it, let's see, between what two speeds must you drive to keep your costs no more than 13 cents per kilometer? Yeah, between 60 kilometers per hour and 40 kilometers per hour. So I'm not sure it's really accurate to put let's just say it's between these two, okay? The one x could equal this, or x could equal that. So it's got to be greater than the 40 but less than the 60. All right, what's the next question here? Is it possible to spend only 10 cents per kilometer? Justify your answer. And I believe the answer is going to be no there. It's not going to be possible because I think what will happen, we will get, when we try to put that in, could this ever equal 10 cents right over here? Let's just say, just do it right there. Could this ever equal 10? And I think the answer is no, because I think we'll get a x squared minus x minus 27, or plus 27, equals 0. We'll get a negative under the radical, and so then that can't work, right? So you'll get x is going to equal the opposite of b, so it'll be 1 plus or minus radical 1 minus 4 times a times c over 2 times 0.01. But see, I think if we look the determinant there, let's look at this. Okay, so we're going to get 1 minus 4 times 0.01 times 27. Yeah, we get a negative under the radical. So that is, it's not going to be a real number. So under the radical, I get negative 0.08 over whatever that is, just 0.02. But it can't, because I get a negative under the radical. That's not possible, right? It's gonna be possible in the complex number plane, but not the real number plane. All right, let's see. So the least number of cents per kilometer occurs when you get the most kilometers per liter of gas. Well, what they're really asking for here is the vertex. This is a parabola. It's a quadratic relationship, and so we want to know, what is going to be that speed. And I think if you graph this, even you can graph it on your calculator. You can see on the calculator, you're going to get something like this, right? And this is going to be where you've got the greatest amount of speed. Remember, speed is right here. It's on the x-axis, right? That's the independent variable. The dependent variable is cost per kilometer. And there's just going to reach a point here. Look, when you go 10 kilometers per hour, it's costing you 28 cents per kilometer to run the car. When you're going 20, it's costing you 21 cents. So it's going down. When you go a little faster, it's costing you even less to run the car. Well, where's going to be the minimum number, the lowest cost per kilometer, and that's going to be at the vertex. And so the key here is just to find the x coordinate of the vertex, because that will tell you what your speed should be. All right, so it's going to be the x coordinate of the vertex is the opposite of b over 2a, right? So it's the opposite of b, which b is -1, so it's going to be opposite of -1 over 2 times a 0.01. And I think that's going to be 50. Let me just confirm that. I think I just did that, but it's going to be, so we can see it's a 1 in the numerator divided by 0.02. Yeah, that's 50 kilometers. Well, yep, 50 kilometers per hour. That's going to be how fast at this vertex point right here. This is going to be 50 kilometers per hour. That's always the speed, right? So you can see the speed. The speed's coming down. Then it gets. That's going to be. It's not the speed coming down. Sorry, the cost is coming down. And now, after you go over 50 kilometers per hour, the cost just goes up. Goes up again. All right, I hope that makes sense for problem 4. I'm not sure I'll get to 12. I had some questions on 12 too. I'll try. And hopefully that will help. And we'll talk to you guys later. Okay, bye.